If you're having difficulty with WebEx, please use the chat window to enter your questions, and our WebEx support team will help you. Let me start by introducing myself and my co-host for today's presentation. My name is Kevin Jones, and I'm with Advantage Industrial Automation. I have 20 plus years of experience working at Advantage Industrial Automation. In the past 5 years, I've been Advantage's subject matter experts on OT cybersecurity and industrial Ethernet networks. I'm a member of the International Society of Automation, Association of Energy Engineers, and a graduate from Georgia Institute of Technology with a bachelor's degree in mechanical engineering. I live north of Atlanta with my wife, who is also my next door neighbor until I married her. I have 4 children that range 27 to 14 years old, and they seem to leave and come back and leave and come back during this phase of our life. We're excited to have you with us today. Now about my co-host, our go-to man for cybersecurity consultation, Rich Wituki, cybersecurity consultant with Schneider Electric, focused on securing industrial side of critical infrastructure in North America. Rich has been with Schneider Electric for 15 years, holding various technical consulting roles. Rich is a certified incident handler and is recognized by ISA as a cybersecurity expert. Rich has a bachelor's degree in science in electrical engineering. Rich has 4 children ranging the age of 31 to 16, and they too seem to come back, leave, and come back. With that said, I'd like to turn it over to Rich.
Thanks, Kevin. Now, I think everybody knows what our life cycle's like. It's our kids, right? Anyway, good morning, everyone. We appreciate your taking the time out of your busy day to join us on this webinar. This is the agenda. So I'm going to do a quick introduction of what the problem is when it comes to cybersecurity, especially on the industrial control side. And then we're going to take a look at the cybersecurity lifecycle. Then we'll follow the cybersecurity lifecycle by diving deep into the cybersecurity lifecycle and looking at each one of the different phases and details. And then finally, I'll give you an example that will bring all this together and then talk more about the Schneider Electric and the Advantage cybersecurity portfolio. The bad thing about this is malware can easily get into our environment. So you've heard of phishing attacks. This is where somebody sends you an email and it looks like it has a legitimate email attachment, but as soon as you click on it, it infects your system. Or maybe it has a URL. Maybe you get something that looks like a legitimate bank statement and you click on a URL to go to your local bank. And what it really is just a compromised website. Guess what? Any of those 2 things, which is simple to do, all of a sudden, now your system is infected. And then we've all heard about the USB drives, right? If I share my files on a USB drive, I might infect myself, I might infect somebody else. So these are all things that we typically have to worry about. Now, some of us are probably saying, yeah, that's true, but really I have an IT department who takes care of all of this. Well, this is partially true. And the reason for that is IT departments are concerned more with protecting information. Their biggest worries are things like we want to make sure that somebody's personal data isn't released, such as their social security numbers, right? We want to make sure that there's no manipulation of data, such as the balance in your bank account. And to a lesser extent, things like making sure their corporate website is up and running. These are all important things, but on the other hand, when it comes to the operations side, so the operations technology viewpoint, we traditionally are more concerned with the safety and of our people and the environment that we have. We don't want things released out into the environment. We don't want, a release of gas into the environment. We don't want people to end up getting hurt with our systems. We're also concerned with our equipment uptime. We want to make sure that it's running and that it's reliable and that our operations continue on. So from a cybersecurity standpoint, while corporate IT, rightly so, is concerned with protecting your personal information, They want to make sure it's not plastered all over the internet or sold on the dark web. We, on the operations side, really don't consider protection of information as our number one priority, because our data is typically not personal, but is more process oriented or production oriented. So we have data such as temperatures, pressures, set points, maybe what material we're producing, those type of things. So we're not so much about protecting the data, we're more about protecting our systems. But don't misunderstand me. I know IT is essential to running the business, but when it comes to the day-to-day operations of producing an end product, whether that end product is the clean water produced by your local municipality or your favorite tasty beverage, this is really what OT concentrates on. And here's a big problem right now, ransomware. So I know we've all heard about ransomware, but let's talk a little bit about it. One technique that has been very profitable for the bad guys is to hack into our corporate systems and encrypt the data. So what they're doing is they encrypt the data so that it's no longer available to the corporation. The reason they do this is so that they can charge this huge ransom, typically in the form of Bitcoin, before they supply us with the keys to decrypt the data. Of course, one thing we can do is to have valid backups of our data. That's one method for restoring our operations without paying this ransom. However, the hackers are really starting to catch on. Now, the latest trend is not only for them to encrypt the data, but also to take your data and to make copies of it for themselves. Here's what they do. When they make the copies of the data, if you do not pay the ransom, the hackers will threaten to publicly release the data. And nobody wants that, especially remember our corporate use of nobody wants this. Our IT guys are really in charge of protecting the data, and they don't want this data to get out. So what happens when they can no longer make money by ransoming data the traditional way, or they can't make money by releasing the data because maybe we start encrypting the data and they have no access to it? Will they start to threaten shutting down our critical operations like our electrical utilities, or maybe even interrupting operations on, let's say, a hydroelectric plant, or maybe even escalating that, creating equipment to fail at our manufacturing facilities, or actually destroying the equipment? How about releasing hazardous chemicals into the environment or causing some of our safety systems to fail? Why not? Why wouldn't they do that? First they encrypt our data, then they threaten to release the data publicly. When this is no longer lucrative, why wouldn't they threaten the very operations we depend on? So the risk of these cyber criminals of being caught and prosecuted is so marginal that even some of the traditional gangs are getting involved. And when I talk about gangs, I mean these street gangs that are actually moving away from the distribution of illicit drugs and other dangerous type of business, because this represents a safer, less risky, and more lucrative market for them. Another challenge we face from the IT department, for instance, the IT department has a responsibility of refreshing their systems on a regular basis. This typically might include major upgrades or changes every few years. This on the OT side, this type of modernization is really unheard of. In fact, some of our systems, such as PLCs, RTUs, and other real-time control systems, have been in operation for 20 plus years. And if we look at the computer, the software, and the operating systems that run our SCADA or HMI or DCS, some of this stuff has been out there for more than 10 years. So this is all antiquated by today's standards. Is it any wonder why IT doesn't want to touch them? To be quite honest, sometimes we don't want to touch them either, right? Major upgrades to corporate IT systems, these typically can happen in a 4-hour outage over the weekend and not have any effect on anyone. Major upgrades to OT systems may actually take several months. Some of these systems may not be fully completed for a year or more. I actually know of one installation that was delayed so long that the system was actually obsolete before the system was installed. So let's take a look at how you can protect your systems. We use a standard cybersecurity lifecycle that consists of these 5 phases: assess, design, implement, monitor, and maintain. So the assess phase, or the assessment phase, is really where we take a look at what vulnerabilities we have. What are our critical assets? We make a list of these critical assets, and we try to determine what happens if somebody attacks one of these assets. What's the risk to our systems? And we look at that risk, and we prioritize the risk based on the relative risk for each one of these assets. So once we assess the systems, we have to figure out how to protect them. And that's really comes in the design phase. So the design phase is really where we start developing the system architecture and determining some of the strategies that we would use to actually defend that architecture. The implement phase is exactly what it sounds like. This is where we actually take the controls that we had in the design phase. So, anytime we're putting cybersecurity on a system, we call those controls. We take those controls and we actually implement those controls. So we install the controls, we configure the controls, we set them up, we do all the training. That's the implement phase. The monitoring phase is really where now we're in an operating environment and we take a look at those controls and we see what's happening with the controls. We look at our networks, we monitor what's happening with our networks. We typically monitor all the changes that are going on in our system, and then we try to respond to those on a regular basis. And then finally, the maintain phase is where we develop those processes and procedures to help support upgrades such as patch management and making sure that we are aware of what's going on so that we can respond to an incident should an incident happen. And when I talk about an incident, this is where something bad happens, whether it's intentional or unintentional. So you might think, why should I use this methodology? Well, the short answer is it's specific to operations technology, not information technology. It's also a proven, well-documented standard that has evolved over the past 18 years. And the standard is a very reliable standard that is part of a well-known organization known as ISA, or the International Society of Automation. I think everybody here is pretty much familiar with ISA themselves. So let's
Rich,
take a quick poll. Yes,
Rich, can you go back to that slide?
sure.
Okay, so here's the question. You used the word controls, and in the world that you play in, cybersecurity, when I think of controls, and I come from the OT side, I'm thinking of things like PLCs, push buttons, pilot lights.
Yep.
And you keep saying the word controls. So are you saying that we're going to be what kind of controls are you talking about? Because I think they're totally different than the kind that is
That's
the OT
right.
side.
Yep,
Could you could you define controls?
Yeah.
The controls you're talking about? Thanks.
Yeah. So obviously, a PLC would help automate a system, right? Would control that system, and maybe you're producing a product. On the other hand, cybersecurity controls typically are being used to help secure your system. So, for instance, a username and password, that's a control. A firewall, that's a control. What your badge? I'll talk about your badges later on. So if you have a badge that you use to get into your corporation, that is actually a control. Those are all cybersecurity controls. A policy for, and I know we all hate passwords. I hate passwords, but a policy for how often you update your passwords, that's considered an administrative control. So those are all controls.
Thanks, Rich. Thanks for clarity there.
No, great point. So, so kind of moving on, let's go to the poll information.
Great. So thanks, Rich. So we have 2 poll questions for you. The first one is, are you an OEM, system integrator, or end user? You can answer that on the right. And then where do you think you are in your cybersecurity life cycle? So the definitions are on the left: assess, design, implement, monitor, and maintain. And we'd ask you to fill in the questions on the right. So we'll give you a minute to do that. And when you're done, please hit the submit button. All right. Fantastic. So you see the poll results. We have about 50-50 end user system integrator, and we are 30% in the assess phase and 42% in the design phase. And we have some people in the maintain phase. So very, very interesting information there. We appreciate that.
Oh, that's excellent. So Kevin, it looks like we have a lot of stuff to talk about, right?
I agree. So why don't you, we have limited time though, so looking
Yes,
forward
we
to
do. All right, let's get into the assess phase. So this is I want to just kind of dive into a little bit on the assess phase and what it means. So the assess phase, this is where we actually go in and we identify what our critical assets are. Now, when I talk about critical assets, these are all things that are computer controlled, right? Otherwise, they wouldn't be cybersecurity under the cybersecurity purview. So computer controlled asset, also physical controls, those type of things. And then we look at those assets and we actually establish a conceptual design, so a design on paper, using what are called zones and conduits. And I'll get into zones and conduits a little bit more, but just briefly, the idea behind a zone is a logical grouping of different assets. So let's say I have 4 production lines. One production line might be a logical grouping. I might have a PLC and an HMI, a couple HMIs in there, and I might have something for storing information. That could be a one logical zone. Or I could say, you know, I want to put all my PLCs together, and that would be a logical zone. Another example of a zone might be where I have my SCADA system. So my SCADA system is a server with software, and I have different workstations that are on there. I might even have an engineering workstation that I use for programming it. That would be a zone. And then the conduits, when I say zones and conduits, the idea there is, how do I communicate from one zone to another zone? So, you know, if I have PLCs and I have a SCADA system, I'm probably going to want to use that SCADA system to monitor my PLCs and to monitor my processes. So that's kind of where the conduits come in, or for communications. So from a high level perspective, I'm designing and I'm assessing my system to see what my zones and conduits are. And then this is where, you know, the rubber really hits the road. Then I want to analyze what my security risk for each zone is. So I want to take each zone and take each conduit and determine what kind of security controls I need to put around there. I'm not going to do that yet. That's going to come in the design phase. But
Hey, Rich,
for now, yes.
the screens are not updating.
Yeah, that's right. I'll get to the other ones in a second here. Sorry. So then I want to analyze the security risk for each one of those zones and conduits, assign a target security level for each zone and conduit, and I'll talk about target levels here. And then I want to document those security requirements. So the security levels, what exactly are the security levels that are out there? So with this standard, we have 4 security levels. I guess you could almost say 5 security levels, where security level 0 would actually be no security, no cybersecurity at all put on it. These 4 security levels, 1 through 4, represent from the lowest to the highest security level. So security level 1 typically protects you against somebody the well-intentioned employee, somebody who doesn't mean to do something wrong, but they might do something wrong. So, for example, there's something known as tailgating, and tailgating is the idea. I have a my badge, and when I go into my company, if somebody sneaks in behind me, that's considered tailgating. But let's say I'm the employee, I'm well-intentioned, and I want to be nice to somebody, and I'm like, I hold the door open for them. That's called piggybacking. So on the one hand, piggybacking might be another employee who's authorized to come in, whereas tailgating is somebody who's sneaking in behind you. So that's the idea behind a well-intentioned, maybe a careless employee who is not doing the right thing, or who doesn't have necessarily the right training in terms of how to use their badge for accessing their companies. Security level 2 is the insider, just like security level 1 might be, but security level 2 might be the disgruntled employee or a contractor that is upset with your company, or could it even be the intruder? This is oftentimes what we call like a script kiddie, somebody who goes in there and tries to get access to your systems just to prove they can do it, or cause your systems to go down in something like you've probably heard of DDoS, or distributed denial of service attack. This is where somebody might send a bunch of information to your website, to end up taking down your website. You could have that same effect on your internal PLCs or SCADA systems or historian that you have on the outside website. So those are the things you have to look at for security level 2. Security level 2, this is how we want to protect against that. Security level 3, now we're talking more about our professional thieves, the people who are really cyber criminals, who are out there trying to hack into your systems. This is also where you would find your terrorists, and these are people who have really good skills. Not like security level 1 and 2, the guys don't have any a skill set. Security level 3, they start to have a pretty good skill set and moderate resources. They got the money and the time to go in and attack your system. These are usually like competitors who are looking for your intellectual property. Now, security level 4, at the highest level, these are your nation states. These are the hardest people to protect to, because they basically have unlimited time and unlimited resource, and they're specifically trying to attack you. A recent one that happened was the attack by the Russians on the Ukraine. This has been happening over several years. Those are the type of attacks that you have to watch out for. One of the other bad things about something like the attack by a nation state is a lot of time there's these artifacts or collateral damage that can happen to other companies that are out there. So security levels are used to help us assess what our system needs to be and what our system currently is. So that, like a target security level versus an actual security level. Then we get to the zones and conduits. So again, zones and conduits. Zones are the logical grouping of devices. So in this example, very simple. I said, okay, let's group all our PLCs together. The SIS, that's like a PLC, but SIS is safety instrumented systems. These are designed to actually make sure your system is safe and that nobody gets hurt, or there's no environmental damage. These systems are designed to keep things from basically blowing up. And you can see why you'd want to separate your PLCs from your SIS, but these different zones might need to communicate to a SCADA system. So you might have a zone that's specifically just for your SCADA, one for your historian, and then of course your corporate is a natural zone. And again, the black lines that you see here are the methods that are being used for communicating between those devices. So think of your networks. This is how we communicate to devices through the different networks. Even though all these systems might be connected one way or another, we still need to look at it. We need to look at the system from a design perspective, from a conceptual design, as being specific devices or systems communicating to specific systems, and that's the idea behind the conduits. So putting it all together, where we have the zones and conduits and the security levels, what I've done is instead of actually putting a number associated with them, I've color coded these. So from the corporate perspective, when it comes to the OT side, who are we going to trust the least? For us on the operation sides, we're going to trust the corporate zone the least because we have absolutely no control. Now, the historian might be sitting in a zone that gives both sides access to it, right? The corporate and the historian. So I might, both of us might have some trust in the historian. So there might be this, a lower security level for the historian. Whereas the SCADA, I bump the security level up for the SCADA because I'm in complete control of the SCADA system. I want to make sure that nobody attacks it. But let's say somebody does attack the SCADA system and brings it down. I can still operate my system with my PLCs. My PLCs are still going to be running. They're automated. I might have to do some manual tweaking. I might have to go up to an HMI in that PLC zone, but at least I still have access and control for it. So I might rank this as a lower security level than my SCADA system. And finally, my safety instrumented system, the things that are keeping things from blowing up, that's going to be the system that I trust the most and the system that I have to secure the most to make sure that nothing happens to that system. And we'll talk about in the design phase how we would design the right controls around those systems in order to protect them. So for our next poll.
Perfect. Thanks, Rich. So the question becomes, if we take a look at the 4 security levels that Rich presented, which security level do you think your organization should target to protect against? So this is not where you're at now, but where you would like to be in the future. So we asked, the poll came up on the right. I would ask you to make your selection for 1, 2, 3, or 4. When you've made your selection, please hit submit. Rich, while we're waiting for the poll questions to come back, we're talking about the assessment phase as it relates to how much time does this phase take in a general engagement with the customer?
That's it's relative. And the reason I say that is, let's say you have a customer that has critical assets all over the place and they have no idea what those assets are. That phase could take a long time to determine what those different assets are. And usually, in the case where we might be helping the customer with this, that might be something that they're going through and identifying on their own. So even though it might take a long time to do it, it doesn't necessarily mean that we're doing a lot of work at this point in time.
Perfect.
So it can vary, but usually, the assessment phase, if I was going to look at what we call kind of a baseline assessment at the initial high-level assessment, we're usually talking anywhere from a couple of days on site and probably about a week. Here recently, because of COVID, we've been doing assessments offsite, and usually it's from doing the assessment and more of an interview process, right? Because we're offsite. From doing that type of assessment to generating the report and the recommendations, we're talking probably about a week's time.
Got it. Thank you. Okay, the results back are in from the poll. So we've got 30% are going for stop employees and vendors. 2, we have keep out immature and skilled people. We have 20%, and with the lion's share being 40% people believe we should protect. They believe they would want to protect against individuals, group hacktivics. I'm glad we don't have people think they need to protect against nation states on the phone. That's good.
Yeah, and Kevin, that's right in line with what we typically see. So, and OT, you're really targeting a security level 3. So that's usually the security level that you're targeting. Now, what happens is when you go through and you do that assessment, you end up assessing what security level are you actually at. So part of that design is closing the gap between what the security level actually is and what your target security level is going to be, which kind of brings us into the next portion, the design and implement phase. So the design and implement phase, this is where we really get into the weeds, and we generate this, we develop a kind of a detailed design, and we walk through that design, and we get other people involved. We get operations involved. We get other teams involved, and we go through and we verify that design. So from a conceptual point, getting it on paper is really important, and then looking at what type of controls we're going to use is very important, because doing it on paper is a lot cheaper than going in and trying to actually implement it, which costs a lot of money. So if we do something wrong, we want to find it on the design phase, and that's part of verifying the design. Then we get into the construction. We actually go in and we're implementing the system, and we validate that system through any kind of testing that needs to be done. So the design phase really, you would think it would be the hardest, but it's not necessarily the hardest, because if you think about the design phase, it's a lot of it's done when we do the risk assessment. So this risk assessment that I was talking about before, that shows you what target security levels you want to be, what the zones and conduits are. This is where we start from that. And the design phase is where we start to implement some of that and put the different controls on there. So let's take a look at how we might look at this system where we have PLCs, SCADA systems historians, and we might protect those systems. So in this case, we have to remember we have to protect the zones and the conduits. And now, one of the other rules that I failed to mention is anytime we have two zones communicating to each other, in other words, we have a conduit, the conduit has to be at the highest security level. So in this case, if I have a safety system, the conduit has to be just as high as the safety system itself. It can't be the SCADA system. So when we protect it, it protect the zone and the conduit also. They have to be at the same level. In this example, that safety system where things can go boom, there's a couple of different ways I can handle that. Maybe I decide to put what's called a data diode in there. And a data diode only allows data to flow in one direction. Reason this is important is because when data flows in one direction, from the SCADA system, I couldn't get to the safety system. There's no way I can do it. It's physically impossible to do it. Other ways of segmenting the network might be using firewalls. So, when I start talking about zones and conduits and segmenting our networks, that's really dividing the networks up. And one of the reasons IT has such a difficulty with this is because of their lack of knowledge when it comes to OT devices, OT assets, and the OT networks themselves. From our perspective on the OT side, what's difficult for us is we don't have the expertise necessarily on how we should actually divide these up. And this is where working between the OT and the IT guys can be very, very successful. So we decide how do we want to protect these devices. And each one of these devices, we set up and write the different policies that we need to use to communicate from one zone to another. So let's take a look between the SCADA zone and the historian. Between these two zones, I have to set up firewall rules on this OT firewall. Now, those firewall rules are actually the policies that I have. Those policies might be I'm only allowing certain certain IP addresses to communicate from the SCADA side to the historian. And maybe I block all communications from all other IP addresses from the historian to the SCADA, for instance. And in those firewall rules, I also do things like I tell which applications that I need access to using something called ports. But that's kind of getting into the nitty gritty. But those policies end up becoming well defined and part of my design document. Once I've done the entire design, then I go through and I actually implement the system. One thing that we always want to worry about when we implement systems is how can these systems grow with us, right? What happens if I need to add new assets to a zone, and how can I make sure that those necessary firewall rules get added, as an example? Well, it's all through documentation, right? So part of the approach of doing this correctly is to make sure I have a method for documenting this. During the implementation phase, once I've gone in and I've configured my different systems up, then I've got to test my systems, validate the systems through that testing, and I've got to teach the people on how to use them. So here's an example, a SCADA system where we have users that have usernames and passwords, and that's how they log on to the SCADA system. That's a security control that keeps everybody else out except for people who belong to that SCADA system. And as simple as it sounds, I need to teach them how to use a username and password. I need to teach them how to change their password, and I need to help train them in understanding the policies for how those passwords might, how often they need to be changed, what the complexity is. That all becomes part of the implementation phase. So moving on, we get to the monitor and the maintain phase. So once we've designed our system and it's actually in operation, then there's about 5 things we need to do. We need to obviously maintain our security. So that's the maintain phase. And we need to monitor our security. But a big piece of this is the management of change, right? So when we change something, how are we making sure that we're documenting it and that the next person who comes along is capable of looking at that? We also want to do periodic vulnerability assessments. So part of part of maintaining a system is making sure we have all the correct patches on those systems. So when we patch a system, we don't want to patch a system that doesn't need to be patched. So we're looking at vulnerabilities all the time and looking at which devices might have specific vulnerabilities. Now, vulnerability is a weakness, right? So, if a new piece of malware comes out, like a new virus, will that affect our system? We need to know those type of things. And often these vulnerabilities come out from the different vendors. Like Schneider Electric might say, "Hey, we found a vulnerability in this system. You need to patch it, or you need to upgrade the firmware," that type of thing. So that's all about the maintenance phase. From a monitoring perspective, we can monitor logs. We can monitor. We can not monitor the traffic on a network. We can monitor the activity, such as how the hard drives on our systems. If you think about it, think about a historian that's storing lots and lots of data, and the hard drive keeps growing. Eventually, that hard drive is going to grow to an extent that it's going to fill up. Now that could be a big problem. So monitoring your resources on your different devices can be important, because you don't want to cause an event, just because you weren't monitoring the right stuff. So let's give some examples on the monitor phase. So if we look at Active Directory, now, when I talk about a directory, for those of us who remember what a phone directory is, a phone directory had our usernames, our address, our usernames, our first name, our last name, our address, our phone numbers. Sometimes they had advertisements. Active Directory is the same idea, except for it also stores your username and your password. So any of us who have ever logged into a system recognize what Active Directory is. And Active Directory is usually there to protect your different systems. So how does this, what does the monitor and maintain phase have to do with this? Well, for example, let's say you have different operators who have different roles assigned to them for a specific SCADA system or a PLC. Let's say that operator leaves the company. Maybe they take a different job or go somewhere else. One of the things we want to make sure we do is we want to make sure we either disable that user or remove that user from the system. There's lots of reason of doing it, but part of it is because maybe we don't think that the operator is going to do anything bad, but we want, we want to reduce the attack surface. We want to reduce the number of ways some bad actor can come in to our system. So that would be the maintain phase. On the monitor side of Active Directory, you also have things like Active Directory logs. So I can go in and I can look at a log and I can see where people have past logging attempts. It's not unusual for somebody to have one or two, failed login attempts. But let's say I find 30 or 40 of these failed logging attempts coming from a computer that it should not be communicating to. That might represent somebody is trying to guess the password. There's lots of ways of doing that, but somebody might be trying to get into your system, or they might be trying to elevate their privilege and get into your system that way. One thing you should know is if you get access to Active Directory and you elevate your privileges, you can own your entire system. So those are the ideas behind the monitor and maintain phase with Active Directory. Now I'll go to another simple one. The management of change, right? So management of change is more on the technical side. So we talked earlier about an asset inventory. Asset inventory is a great example. And if I was going to give everybody here a homework assignment, this would be the very first thing that I would do. I would go into my business and I would look at all the assets that I have and I would make sure that I inventoried them. And one of the easiest ways to do that is just open an Excel spreadsheet, inventory the different assets that you have, and go in and get all the information, such as what's the firmware of this hardware, what type of hardware is it, where is it located, maybe what software am I running, what version of software am I running. Those are the type of things that you want to do when it comes to asset inventory. Now, as part of a life cycle, let's say I start to mature in this life cycle, and I go from just having my own little spreadsheet, and I mature a little bit, and I said, you know what? I need policies and procedures regarding this because multiple people are starting to access these spreadsheets. So I create policies and procedures. Anytime there's an asset that's added or changed or modified, they need to come in and they need to update these spreadsheets. And then maybe even it gets to the point where either I buy software or I write my own software, and I have a backend database collecting all this information. The nice thing about a backend database might be the fact that, hey, I go in and I recognize a vulnerability and I put it in my system, and immediately it shows me the 3 or 4 different pieces of hardware or pieces of software that need to be updated in order to get rid of that vulnerability. And then finally, as we mature in the process, automating this is a big deal. And there are systems out there that help you automate this inventory, that help recognize when something gets plugged in. The other thing is, hey, something got plugged in and it doesn't belong there. Maybe I don't see that with my typical, manual asset inventory that I'm using the Excel spreadsheet, but maybe I do see that in an automated system. So this becomes very, very, very important and ends up being used in lots of other ways. So believe it or not, that is the cybersecurity life cycle. So remember, as mentioned earlier, that this is a standard methodology, and it's really proven itself over many, many years. So it should also be apparent from our discussions that this is a sustainable cybersecurity life cycle. It's not something you do once and you throw it away. It can be used over and over again, and it's a great way with continuing to mature during your cybersecurity life cycle? I think we have another poll coming up here, Kevin.
Fantastic. Thanks, Rich. What do you think the most important? What do you think is most important to your organization from a cybersecurity perspective at this time? So we have some questions on the left, and if you can match it up to the answers on the right, that'd be great. And when you've done selecting your choices, you can select more than one. Go ahead and hit submit. And if anybody has any questions, feel free to add them into the Q&A section. Fantastic, Rich. So we have assessment at 36%. The highest number we have at physical, local, and remote access control. And disaster recovery is coming in second after physical, with it's coming in second. Assessment's coming in third, and tied with network security. What do you make of those numbers, Rich?
Yeah, so those are good. Those are good numbers. I'll tell you one thing. I know a lot of people are so physical, local, and remote access. So when we look at the physical access controls, typically you can protect anything physically. I can put a fence around something. I can put a lock around something. I can monitor. I can monitor systems with cameras. So there's a lot you can do with physical. My guess is the reason that one ranked so high is because with COVID right now, so many people are working remotely, and there's been a lot of activity trying to find vulnerabilities and to remote access systems. To be honest, I would say probably 80% of all the work that we've done on the cybersecurity side here has been on the remote access control side of things. The disaster recovery is always a big one because disaster recovery is all about ransomware, right? So what happens when somebody takes over my system? And I've personally worked on one of those systems. I did not enjoy it because it took about a week of my life away. And disaster recovery is never. It's there's a whole school of thought on that and how to attack it. And but yeah, disaster recovery is pretty high up there. So I actually probably address one of the lower ones that we have on there, and that's our patch management. So let me just give you an idea of why I picked patch management. The main reason it's really because it's something that we're all familiar with, and it seems like it would be really simple, right? We all know we need to patch our industrial control systems, and the part of the reason is we have an obligation to maintain these systems and make sure they're safe and secure, as well as remaining reliable and performing as intended. However, patching is a real challenge when it comes to our industrial control systems. And part of the reason is there's really two opposing schools of thoughts. The first thought is, on the IT philosophy side, is we should patch everything as soon as possible. Of course, from a philosophical sense, that makes a lot of sense, right? And just take a look at the last month's Microsoft patching cycle. Last month, Microsoft released over 120 released a patch to patch over 120 security holes in Windows. Out of the 120 bugs that they found, 17 of these address vulnerabilities that Microsoft themselves rated as critical. So what does that mean by being critical? It means that it can be exploited by hackers and to gain remote access and complete control of your system with little or no help from the users. And what I mean by little or no help from the users is the user has to do something. Typically, they have to, they have to click on a URL or they have to open an email attachment. But that's, pretty much all they have to do. And now all of a sudden, these hackers have access to your system and they own your system, right? And the second school of thought, though, is on the OT side, right? How, on the operations side, it's if it's not broke, don't fix it. In other words, we should not patch a production system unless there's a reason to do it, unless something is broke and we know it's not going to create any new problems. Part of the reason this approach is usually preferred on the operation side is because anytime you patch something, it means that there could be an incompatibility between the patch and the control system that you're running, right? So if I'm patching my SCADA system, maybe there's I introduce a new vulnerability in that SCADA system, and the system stops working. So I want to kind of avoid those from the operation side. Again, if it's not fixed, don't break it, right? Ironically, both the IT and the OT philosophies have the same rationalization. We're both concerned with risk. So newly discovered vulnerabilities result in increased risk to our systems, which compels us to patch these systems. Likewise, the process of patching a production system or even an application could result in unintended consequences. This kind of compels us not to patch these systems. And I think there's usually one other factor that's getting bigger and bigger and bigger when it comes to patching. And this is not going away, but it's the negative impact that it has on both the IT and the OT's resources. So it means an increased workload and an increased usage of resources for both IT and OT. Now, we're running out of time, so I'll just very quickly. This a best practice for patching your system. You gather and analyze any patch information for each device. You install and verify the patches on a test system in a way that accurately reflects the production environment. This is sometimes referred to as smoke testing. Then you ensure that the backups are created before you patch and after you patch. Once you do the backups, you install and verify the patches on the actual production system. Of course, you're going to still continue to test the production system to make sure that there's proper operation, and you'll do this before turning the system back over to operations. And finally, you want to track all the necessary changes through the appropriate documentation. Now, there's a lot more activities that surround an actual patch management program that are required by that, and we could always get into that at some other time. So I encourage anybody who wants to talk more about it to come to us and leave us an email or a phone call. So essentially, what I've shown you is a cybersecurity lifecycle that can address lots of the different security issues that we have when it comes to our automated control systems. If you look at it, the life cycle is practical and it's a proven and sustainable life cycle. That's also provided by a very well-known and recognized organization called ISA. So we at Schneider Electric and Advantage use this 5-phase life cycle to secure your operations. So we do it with our own operations. We can help you secure your operations. And what I'm showing you here is the different cybersecurity portfolio that we have. So all these are different solutions that we can use as part of that cybersecurity lifecycle to help protect your systems from any of these cybersecurity vulnerabilities. And finally, I guess it's always important to talk a little bit about our credentials. Here in North America, we have a global cybersecurity group, but in North America alone, we have 20 consultants, just consultants who are dedicated to running cybersecurity projects. They're not specific to SCADA systems or PLCs or DCS or anything else. They're specific to running cybersecurity projects. And they have lots of different credentials and certifications, as you can see below. They understand the IT side as well as the OT side, but again, we concentrate on the operations side when it comes to cybersecurity. And one final thing I'll say about our cybersecurity guys is they're pretty much agnostic. They don't care if we're working. We care. I want them to work on Schneider Electric products, but our guys don't. They really don't care who's PLCs, who's DCS, who's SCADA systems. We protect those systems using the same methodology and the same techniques. So finally, thanks again for your time. We realize protecting your industrial control systems against malicious attacks is a really high priority for everyone, including ourselves. Since this cybersecurity lifecycle is really targeted towards operations, it should be easy for you to adopt. It's a life cycle that you can really live with. And again, I keep repeating this, but it's practical, sustainable, and it's a standard that's been proven for many years. We at Schneider Electric are always happy to help. Schneider Electric and Advantage are always happy to help. And we encourage you just to come out and contact either myself, Rich Watuki, or Kevin Jones.
That's exactly right, Rich. And for those of you who have an Advantage salesman that's assigned to you that you can reach out to them also, and they'll contact us. So we are at the end of our hour. We appreciate everyone's time, and we look forward to hearing from those that are interested. And you all have a great day.